Hello world, Lisa Friedrichsen here, your friend and computer science professor with another short screencast from javascript.info, the Modern JavaScript tutorial. We are in 2.14 functions, and there were a couple of important aspects of functions that we didn't cover in the last YouTube that I want to pick up in this YouTube. And that is the issue of parameters and returning a value. Here's my little JavaScript code. We know that functions help us organize, document, control, and reuse code. But what is a parameter? Well, a parameter is a variable that we put inside the parentheses that contains information that's passed to the function when we run it. So for example, if I prompted for a user, I'll refresh my page, I'll prompt for my username. Now the variable user contains the string Lisa, and when I run this function hello, I could pass in that variable to that function. If my person variable is equal to Lisa, then console.log hi Professor Lisa. Let's say world and enter, then I get welcome world because person information that I pass to the person argument is not equal to Lisa. I'm running this else statement, console.log world. In a nutshell, person is a variable that's used within the definition of the function. It's not available outside of the function. If I want to provide a default value, I can do it with this type of statement. If I don't pass any information to the goodbye function, I'll say goodbye without passing any information, then I get a default value of mystery person. I'm assigning person to mystery person if I don't provide any information for that. But I can provide either a variable name, goodbye user, which is going to say thanks for visiting Lisa, or I can pass a string, Tony, and now it will say thanks for visiting Tony. So we set up functions with parameters that need to be passed into the function when that function runs and are used in the evaluation of that function. I believe that technically when you define a function and you have pieces of information that you're passing into that function, those pieces of information are defined as parameters. So this hello function would have one parameter person. I believe that when we actually run the function, I've got Lisa now in the user variable. When we run the function with either a variable name such as user, or when we run the function with a string or any other piece of data, user or Doug would be considered the arguments that we're passing the function. But for the most part, the terms parameter and argument you'll hear used interchangeably. Now I've got a second set of functions that I want to use to demonstrate the return statement. You might have noticed in the console that every time we run a function, we get undefined as returned from that function. And that's because we did not have a return statement in those previous functions. So a function always returns something, and if there's no return statement, it returns undefined. And sometimes that's fine, because sometimes all we want that function to do is a side effect, such as change a style or display a message or make a calculation that appears on the screen, and we don't need it to return anything to another part of the program. However, in this little case, I've created a couple variables here. Total, I've set it to be equal to 100, and state, we're going to prompt for state value. And what I'm trying to simulate is a grand total on a shopping cart, and the fact that you'd have to add tax and shipping to that grand total. So because the grand total is three pieces of information, the subtotal on the shopping cart, the tax, and the shipping, we might want to break those calculations into separate functions and then compose them together to get the grand total. A best practice of programming is to generally break every task out into its own function. So these functions need to be able to pass information from one function to the next as the grand total is calculated. The function on add tax just looks to see if the state value is equal to California, and if so, we're going to add a 10% tax by multiplying the total by 1.1. The add shipping function then checks to see if the state is equal to California, and if so, adds $25 to the total. And down here in the calculate total function, I've got two lines. We're going to run the add tax function, which is going to return the total, and then we're going to run the add shipping function, which is going to take that total, add $25 to it if the state is California, and return that total, and the entire function then will return the grand total. Let's save this code and refresh our web page, and now we have interstate, and we're going to try CA here and click OK. And now we have the state variable, which equals CA in our JavaScript environment. And if I run the calculate total function, and notice that this function does not have any parameters, it's going to return total, which has been calculated at 135. Now, how did we get to that 135? Well, we started with our total equal to 100, and we ran the add tax function. The add tax function checks to see if state is equal to California and changes the total, reassigns it to whatever it was, 100 times 1.1. It's going to make total 110. It returns total. So then we run the add shipping function, which checks again to see if it's equal to California, takes the current total, which is 110, and adds $25 to it and returns it. And that's 135. To see the steps, we might want to console log before and after each one of these functions that's running in the calculate total function. So I'll save and refresh again, enter CA for the state, and then run the calculate total function again. And I'm getting a console log. The initial total was 100. After tax, when we multiply by 1.1, we're getting 110 in this tiny fraction. I'll show you how to deal with that. And then after shipping, we're adding 25 to 110, and that's returning 135. Now, anytime you do math with decimal points, you run into this problem of decimal to binary conversion, where sometimes our decimal system doesn't convert perfectly into the binary ones and zeros that the computer uses. One way to deal with this is to multiply by whole numbers and then at the end divide by whatever is necessary to convert that value back into a decimal value. So let's multiply by whole numbers and then at the very end divide by 10 and see how this runs. I'm going to refresh, put CA in a state, and run my calculate total function, and now I'm getting integer numbers because I completed my math on integers and didn't convert back to a decimal equivalent until the very end. That's a common trick in JavaScript, and I have an entirely different YouTube on why 0.1 plus 0.2 does not equal 0.3 if you want to dive into decimal to binary more thoroughly. The point here, however, is that many functions have return values, and the reason they have return values is because they're going to be composed. One final note about the return statement. As soon as that function hits the return statement, it is done. There would be no point in console logging or writing any statements after the return statement because they will not be read by the function. Thank you.